Hello everyone, in this segment we are going to see some set identities, means some basic properties of set, and these basic properties are true for all sets. So if we have two set A and B, okay, so let's just draw two set. So if we have two set A and B, all right, A intersection B will be a subset of A. So let me draw the set like that, and this is our A intersection B. So A intersection B will be subset of A. So obviously this is true because A intersection B will contain all the elements which is both in A and B. So this one is going to be a subset of A. And this is also true for A intersection B will be a subset of B. Okay. So from the picture we can see that. Now A will be a subset of A union B. So A union B means the combination of A union B. So all the elements which are either in A or in B. So obviously the A is going to be a subset of A union B. So the same is true for B. B is going to be subset of A union B. So if A is a subset of B and B is a subset of C, then A will be subset of C. Okay, so for that we can draw a picture like that. So let's see A is subset of B. That means we have B and here we have another set A. A is subset of B means all the elements of A is also all the elements in B. Okay. Now we are saying that B is a subset of C. Means there are another larger set here C. Okay. So all the elements are in B is also an elements in C. Okay, so then from the picture we can see that A is going to be a subset of C. A intersection A complement is a null set. So let's see, this is our set A and this is our universal set. Okay, so this is our universal set. A complement means actually all the elements that's not in the A. Okay, so let's see, there we have 1 2 and complement has 3 5. Okay, so A complement means all the elements that's not in the A. Okay, so 3 5 would be in A complement and 1 2 is A. All right, so then if we make an intersection of all the elements of A and with all the elements that's not in A, that is going to give us a null set. Complement of A means double complement of A is going to give us the same set. So from the figure you can see that A complement is all the elements that's not in A. So it will be 3 and 5. Now if we make a double complement of this, that means all the elements that's not in the complement of A. So it will be 1 and 2. So this is same as set A. Okay. A union B equals to A minus B union B minus A union A intersection B. Okay, so we can actually like draw a very nice Venn diagram to prove that, but let me just tell you. So A minus B means all the elements that's in A but not in B. Okay, so only in A. So B minus A means all the elements that's only in B, not in A. Okay, and A intersection B means all the elements that's both in A and B. Okay, altogether they are going to construct the elements that are both in A or that are either in A or B, which is A union B. Okay, so I can draw a Venn diagram like that. So let me use some different color. So the blue shade, you can see the blue shade means A minus B. Okay, which are only in A, not in B. All right. So the black one, I am giving the black one, they are B minus A. So which are only in B, not in A. Okay. now the green one I am drawing, they are A intersection B. Okay, now if you make a union of all of them, you can see that that's actually A union B. All right. So there are some there are some other law which are true for all of the set. Okay, we also saw that for our proportional logic also, they are true for our proportional logic. Say for example the distributive law. So if we have a set like that, A union B intersection C, so we can actually distribute this one, the union, for both B and C. So A union B intersection A union C. Okay, so let's see for the example. Okay, so let's see for the example, we can also prove it like by using different colors. So I'm going to show you just for only for one of them. Okay, then it will be easier for other law. So let's see, use a black color. So B intersection C, which is B intersection C? So B intersection C is the black one. So this one is B intersection C. Okay, and this one is our A. All right, so this one is our A. So it's actually easily we can find out which is A union B intersection C. So this is our A union B intersection C. This is okay. Now let's find out what is our A union B and what is our A union C, and we are going to try to make an intersection out of them. Okay, so let's use red. A union B. So A union B means actually this whole thing. I'm going to just draw the perimeter. So this is our A union B. Okay, A union C is A so this is our A union C. Okay, so the blue is our A union C. Now this blue is our A union C and the red is our A union B. Now can you find out the intersection of this red and blue? So where we have both red and blue together. Okay, all right, so yeah, blue. So for blue actually the blue will be also here. All right, also here, and the red, let me show you, and the red are also here. Okay, so now you can see that the intersection means actually now let me use a green color. Okay, so the intersection are actually this one. Okay, so which was our A union B intersection C. All right, the second one is we are distributing the intersection law. So we can distributing this intersection to all of these B and C. So that will make it A intersection B union A intersection C. So here you can see that this is our B union C. The B union C is, here is our B and here is our C. Okay, and if we make an intersection with B union C, all right, so this is our result. This is our result. Okay, now you can actually using this three ball, you can using this three round shape ball, you can actually try to find out what is our A intersection B and what is our A intersection C and make a union, because it's actually clear. So this is our A, this is our A intersection B. Okay, and this one is our A intersection C, and make a union of them, it will give you this region. Okay, So I mean, we can also make this prove this much more carefully. So what we can do, when we identify these three set, we can actually mark them. Okay, we can give some value into them. All right. So give some value means they all are actually set. So each here each of the region, each mm, unique region, we can give them a name with a set. Okay. For example, like this region has a name set 1, this region has a name set 2, set 3, like that. Then we can actually prove them much more carefully. Okay, so remember the discrete structure, that in this discrete structure the purpose of learning discrete structure is that we want to create a mathematical formulation for every problem. So you have a problem, you can you find a solution, you know that in your eye you know that that is true, but that's not everything. We have to actually prove that, and we have to prove it mathematically. Okay, so there is another way to prove them or verify this more carefully. So when you have these three set, so when you have these three set, so there are some region, it is going to create some more different region. Some region is only for A, only for the items in A, some are for A union B, some are for A intersection B, like that. So give each independent region a set, and then you can actually prove them easily. So for example, that's your A. A means S1, S2, S4, S5, and union of them. So your B means B is S2, S3, S4, S5, union of them. C means S5, S4, S6, and S7, union of them. Okay. Now you can easily prove by doing the set operation. All right. So in your left hand side, you are going to calculate it like that. Then do the calculation also for right hand side. So if you found them the same result, that means they are equal. So that means this prove the distributive law. So De Morgan's law. So if you remember the De Morgan's law, we also talked about that in our propositional logic. Okay, so if we have a two set A union B, and complement of them, it is equal to A complement intersection B complement. Okay, so let's try to prove them by drawing some figure. So this one, and here we have the universal set. Here we have A, let's see, this is our A and this is our B. Okay, so A complement means all the elements that's not in A. So we can see that the shaded area is our A complement. So here B complements means all the elements that's not in B. So the shaded area here is B complement. Now let's try to find out. So A union B is the white one, and if we consider the shaded area means A union B and complement of A union B. So A union B means this white region. Okay, this one is our A union B, and all the shaded area is our complement of A union B. Okay, all right. Now if you look at these two pictures, you can find out what is the intersection of A complement and A B complement. Okay, so in this A complement, you can see this region. This I mean all this region are in A complement, and here we have all this region in B complement. So if we make an intersection of them, we are going to find out these. Okay, beyond this region, these are actually both in A complement and both in B complement. Okay, so again, for complement of A intersection B equals to A complement union B complement. Okay, so this is our A complement, this is our B complement. So let's try to find out what is the region which is both in which is the complement of A intersection B. Okay, So A intersection B. A intersection B means actually this one is our A intersection B. Okay. So A intersection B means this region. So complement of A intersection B is going to be all of the region. Okay. Other than that. Now from there, from these two picture, find out what is going to be union of A complement and B complement. Okay. So these are all region which is in A complement. These are all region which is in B complement. So only this is going not to be the part of in both of this union. Okay. Other than that, all of them are going to be a part of A complement union B complement. All right, we'll be back in the next segment.